Hello everyone, welcome back to Code Odyssey Hub, and today let's deep dive into the HLD or high level design of the fascinating world of web crawler, wherein it's nothing but a magical program which the big search engines like Google use, and for that they monitor it, they collect the data for research and monitoring to make changes whenever and wherever needed. Okay, so we'll do the HLD of web crawler, but before that, let's begin with defining what does a web crawler mean. So it's nothing but just a program, as I said, which starts with a set of seed URLs. It downloads the web pages, extract the links out of it, and then follows them to crawl with. This process keeps on repeating until all the URLs has been visited. Now, following that, since we are doing the high level design in an interview, we have to start with defining the function and the non functional requirements, which is nothing but FR and NFR. For this particular video, I have kept three set of FRs and NFRs. So for functional requirement, for the first functional requirement that I have kept is start with browsing through the set of seed URLs that we have. Post that, we have to extract the text out of it and store it in our database. The third step would be crawling for a specified number of times. So this can be 5 days, 4 days, 3 days, whatever the interviewer has specified it to you. So this is a good point to ask question in order to build that communication with your interviewer. When we have that, the second process that we have is defining the non-functional requirements that we have. Basically, when we are talking about NFRs, we talk about the fault tolerance, politeness, scalability, storage, etc., and the traffic that we will be getting. So for this particular video, I have kept the scalability. The system should be scalable enough to handle 10 billion URLs or pages that we have with an average size of 2 MB. Now again, there can be a lot more large files that we might need to crawl. We have to take a decision whether if you want to crawl those files or not, and what would be the average size that you want to keep. You want to compress the data, or how do you want to handle it? Post that, we also have to talk about the system should be fault tolerant. How are you dealing with the failures, and the third one would be the politeness. Now, what does politeness mean? It means nothing but how frequent you want a particular website to be visited again. Let's say for the first time you are not able to process that, you want to put it back to the queue or any other data structure that you are using, the design component, how frequent you want to visit again. So this would be taken care by the politeness keyword. Okay, so this is basically our FRs and NFRs. Now talking about the core entities. So what does our entity structure look like? How many database or you want to keep? So for, let's say, what are steps we have? When we get the set of seed URLs, you want to go through the domain resolver to get the IP and download the HTML page, right? So definitely we want one of the database for our DNS resolver. Now, what are details you want to store in this particular DNS resolver? So one thing would be my domain. After domain, oh, let me keep um, the text to black itself. So this would be my domain. I want to keep the domain details. I want to keep the robot text file here. Now, what is robot text file? Robot text file is nothing but a file which will specify which all websites to visit and how frequent you want to visit that. There can be many more configuration details as well, but just to begin with or keep the basic configuration, these all details we have to keep in our domains level, just to make sure that we are not visiting a private website or anything else. So I'll give you a text or a sample what does a robot text file looks like, but for our entity this should be saved. And now after that you want to specify the crawl delay. Now again, the crawl delay can be kept in inside the robot text file again. And what is the last crawl time? You want to save it. And what is the request rate? So these would be some of the details that you want to store in your domain level database. Okay, now once we have this, what is the second set of database that you want to keep? So I would want to keep my second set of database as the URL metadatabase. Now, what are the values that you are going to store over there? So I would want to store the values like URL first is definitely the URL. What was the status of URL? Has it been visited? It has been crawled, not processed, not processed. Those are status you have to define. Next thing would be storing the depth. Now, why would you want to store the depth of the particular URL? In order to avoid the crawl loop that we might encounter later point of time because of some malicious website or because of any other reason, right? So we want to store the depth of the particular URL that has been visited. Now again, here also you want to store the last crawl time. You want to store S3 path as well. Why would you want to store the S3 path? Because we can link this S3 path to our the text database that we have, which would be our last set of our last entity. And in this database, we can store sorry we will store the S3 path, we'll store the timestamp, and we can also, what are things we can store? Yeah, since we have talked about the NFR, the file size, we can also store the size of the file. What is the file size? Just for our reference or for monitoring purpose, what is the average size that we are getting? So like I mentioned, this would be our domain entity. This would be our URL metadata. And this would be our text metadata or text file. We can here you can make use of S3 or DynamoDB. Why we are not going with SQL database? Any guesses? Obviously, because we are not dealing with complex relationships over here. It's just a basic web crawler that we have to design, which can be taken care by NoSQL database or the DocumentDB that we have. So this can be done by any of the S3 or DynamoDB. For the rest of the other ones, we can make use of DynamoDB as our database type. So yeah, I think this looks good as our core entity. Following core entity, what would be our next step when we are designing our HLD? I would say it would be APIs. How are you going to design your APIs? Now, what all APIs do we need for creating this web crawler? The first would be definitely, I would say, the post call that you want to store all the seed URLs for which, okay? So what would this be? It can be basically a crawl database, and where the request body should basically look like, let's say, seed URLs, which will have an array of all the URLs that the system has. Let's say, for example, it would be example.com. The next would be, let's say, HTTP, another example.com. Once we have this, we can close this, and the next key value that we can pass is basically the crawl ID, because we can have multiple crawlers, right? So you would want to store which URLs has been passed to which particular crawler. So for that, we can provide basically any crawl ID with any number. So this should be our post API look like. The next API that we want to design is basically get API, because we want to get the details of particular URL or particular crawl ID. At that point of time, we can basically design the get API with the path param itself as crawl ID. What else? I would say the next API or the last API that we can create is getting the text. Okay, so here we can pass the query parameters. It can be the crawl ID, it can be limit, how many limits you want to keep for that text. You can pass the URL, which can again be optional. And lastly, you can also pass the offset, which will be default to 0, and it can be an optional parameter once again. So this would be the API's design that we can have. And now we have the APIs listed. What next? let's go with the data flow. What does the data flow look like for designing the crawling process? First thing, as I was repeating from the very beginning of the video, it would be taking up the set of seeds from the frontier manager. And we can also fetch basically the IDs from the DNS resolver. Okay. Yeah, or we can keep this as step 2. So yeah, first thing would be taking seed from the frontier manager. We'll pass the seed from to the queue. Next step would be fetching the ID from the DNS resolver to get the page. Once we have this, we would want to basically fetch the page. We have fetched the ID. From the ID, we have to fetch the page in order to download the HTML page. So from the IP, not the ID. I'm so sorry. So from the IP, you would want to download or fetch the page. Once you have the page, you would want to extract the links or extract the text from HTML. Once you have the text, the next step would be storing the text to our database, the metadata database. Once you have the text, you have to extract the link out of it and pass it to queue for further processing. And once you have passed it to, the final step would be repeat all the above steps until all URLs are processed. So this would be the data flow look like. We are getting the seed, fetching the IP, from the IP, downloading the HTML page, extracting the text out of it, storing it for our monitoring purpose, extracting the link out of the text, passing it back to the queue, and redo this particular process until our entire URLs have been processed. We have the data flow now. What next? Yes, it's defining or diagramming, drawing the high level design. So let's draw this. We know the data flow. First thing would be getting the queue. Let's get the queue. I don't have the pipeline, so I'm just making this as queue. I'll make this as frontier manager, which is nothing but an XQSQ for our case. Okay, so we have the queue over here. From the so let me write the text just to be more clear. So we'll send the seed to frontier. The frontier manager will process it. Once we have this, the next step is the DNS resolver, right? Get the DNS. So we'll be having DNS resolver. So we'll send these particular URLs or the seed to DNS resolver to fetch the IP. Now, once we have the IP, here what you want to do is you can basically, the next step would be the component of fetcher, right? So you can directly send it to the fetcher component, which can be Kubernetes or it can be anything else. So let's create a fetcher component. So we'll send the IP to the fetcher. What would the fetcher do? It will get the HTML page. Now, once you have the HTML page over here, the next step would be parsing to extract the details, right? So you would want to have a parser. You get the HTML page, you have to send it to the extract the links out of it. So for that, you need a parser, which will basically extract links out of the HTML page. Now at this point of time, I would want to have the database. So I can basically copy this particular metadata and paste it over here so that both my fetcher and parser, they can store the database at the same time. And not just this, for our DNS as well, we need this particular domain database, which is the DynamoDB, right? So let's get this and paste it over here. So here, if we zoom in now, we have the DNS resolver, which will have the robots.txt file. Oh, I'm so sorry, I didn't. Okay, I have it now. So DNS resolver will go through the robots.txt file, figure out what is the delay, what all websites are allowed or not. So let's write what all things we can write in the robots.txt file. We can have user agent to tell what all URLs you have to crawl. What is disallowed to crawl? Let's say for now all the private pages are disallowed. And what is the crawl delay? I would want to have 10 seconds at the crawl, as the crawl delay. So the last crawl will let me know is the crawl delay has been passed or not. If it's passed, at that point of time, I'll send it back to the fetcher. If it hasn't been passed yet, then I'll send it back to my frontier manager. So if the crawl delay not passed, at that point of time, I would want to send it back to the frontier manager. Else I'll pass it on to the fetcher. I think this looks good. So just to do a review again, we'll have a set of seed in the frontier. We'll send it back to frontier manager. Here we can have a Redis cluster which will take care of the rate limiting, and it will be the frontier manager. Basically, it can be Q, it can be Kafka or SQS. I would personally go with SQS. Why? Because basically it has everything configured, be it the DLQ process and also the visibility process that we want to configure. All everything would be have been there in the frontier manager in SQS if we are taking it. Once we have it, we'll pass it to DNS to get the IP of the domain. Once we have the IP, we'll check the robots.txt file for if that particular URL is private or not. If it's not private, it will check the crawl delay and see the last crawl, match it with it. If it hasn't been passed, it will send it back. If this has been passed, it will send next to fetcher, which will get the HTML page downloaded, save it to my URL metadata and the text metadata that we have. Here we have to store the text metadata as well. And after that, we have to send it back to parser to extract the links. Once the extraction process is done, we'll send the links back to our frontier. So let me take this, or let's keep this to avoid any complexion, and I'll get this over here. Okay, so yeah, this looks good. Once we have this will send it back. Not this. Let's do the arrow. It will send it back to the frontier manager. I think this looks good. Now, how about the looping process that we have discussed at the very beginning? So the crawl loop, we can avoid it by using crawl delay that we have talked about. Not just this, how would you want to handle the dynamic content? Though the dynamic content can be handled by something called as Puppeteer tool, which can handle this. We can read more about it in our later videos. And the last thing would be handling the large files. Now, if we have more than 2 MB files, there can be two steps. One is we can just check the content length, and the files which are greater than 2 MB, we can ignore those files. And if we want to use or crawl through those files, is when we can always compress it and crawl through it once again. So this would be some of the key things that we can talk about more in our interview based on the time bandwidth we have. But other than that, I think this would be the overall HLD architecture for a web crawler. So just to recap, we have defined what does a web crawler mean, functional and non-functional requirements, what are the core entities, we have defined all the type of database that we'll be needing. We design the APIs that we have for post and get calls, define the data flow, and finally we architected this particular design for our web crawler. If there's any other doubt, please let me know in our comment section. I'll get back to you in our next video. Okay, thank you. Have a good day. Bye bye.